Oh man, you guys. So, this is the problem of all problems. We are going to use what we just used in our previous example problems, and those will give us a list of potential zeros. And in these, we're actually going to be finding all the zeros using this rational zero theorem. Okay, so typically, you guys, when you start the problem, you're going to do the p, q's, and p over q's. But if you notice, this was the same polynomial I gave you in the previous example problem. Okay, and technically this should have an f of x. I'm sorry. It should say f of x equals all that. My bad. All right, but anyways, technically, in the previous problem that I just worked for you, if you notice, these are the same polynomials. So, I already found the p's, q's, and p over q's. So to save us some time, I'm just going to list out what I got from the previous example for my p over q's. These are the numbers we focus on to help us find zero. So I'm going to start by listing my p over q values. All right. So my p over q values from the previous problem were plus or minus 1, which I'm actually going to list them in order because I like to list them in order. You don't have to, but I think it kind of helps if it's organized. So plus or minus 1/2, plus or minus 3/2. So here, plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 8, plus or minus 12, plus or minus 16, plus or minus 24, and plus or minus 48. Okay, so these are a list of potential zeros. Okay, that will help us to reduce this equation down to find the zeros and to find factored form. Okay, so this one's a little harder because we don't have a graph to look at to kind of know what the zeros are already going to be. But any of these could be a zero. But you're probably like, holy hot dog, Miss Long, that's going to be a lot of synthetic division because there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 of these, plus we have all the positives and all the negatives. So really, that's like 24 potential zeros that I could test. And that's a lot, and nobody's got time for all that. So I've got some tricks to help you to eliminate some of these options so we can figure out what the actual zeros are and which ones are the wannabe zeros. Okay, so what we're going to do, we're going to pick any number we feel like picking from this list of zeros, which, I don't know, I think that, I think 6 would be good. I have a really good feeling about positive 6, so that's what I'm going to pick. I have just a really good feeling. Okay, so I'm going to pick 6, and these numbers, you guys, are the ones that go in the box. So these go in the box of synthetic. Okay, so I'm going to put my 6 in the box. Okay, so again, you get to pick any of these that you want. Okay, and remember, if it is a 0, because this is our 0 potentially, I don't know yet. If it is a 0, my remainder should be 0 when I get done, which will mean this is a 0, and then I can write it in factored form. Alright, so for synthetic division, I'm going to line up my exponents. My highest exponent is x to the 4th. So you got x to the 4th, x to the 3rd, x squared, x to the 1st, and x to the 0. Alright, and then I write the numbers in front of these variables underneath these. So I have 2, negative 3, negative 24, 4, and 48. Holy hot dog, and that's positive too, Miss Long. Jeez. Alright, so I've written my coefficients down. Alright, let's do some synthetic division and see what magical things will happen. Alright, so I'm going to bring down my first number. I'm going to multiply this to my boxy. 2 times 6 is 12. Slide it on over. Negative 3 plus 12 is 9. Alright, multiply 9 to the 6. So 9 times 6 is 54. Slide it on over. Negative 24 plus 54 is 30. 30 times 6 multiplied to the boxy. I get 180. 180 plus 4 is 184. And lastly, 184 times 6. Let me do this off to the side. Let's see. Holy hot dog, that's a big number. 1,104. And I'm going to add it to 48. So I'll get 12, carry the 1, 4, 5, 1. All right, so I end up with 1,152. Okay, remember, in order for this to be a 0, my remainder should be a 0. But if you see, you guys, I didn't get a remainder of 0. So what this means is this is not one of my zeros. So this is not a 0 or a factor, which makes us sad. But there's something useful that we can get out of this. Do you guys notice all the signs below my division bar? Okay, what are all the signs? Positives or negatives? They're all positives. Do you guys see that? I got a positive sign, a positive sign, positive sign, positive sign, and positive sign. Okay, if you guys see this happen, if you find out that something's not a factor, so you don't get a remainder of 0, but you get all the positives, what this means you have found is something called an upper bound. And what an upper bound is, you guys, this means that there aren't any zeros above positive 6 that will work. This is the highest 0 that will work right now. Okay, which is not even a 0, but there aren't any zeros that are above 6. This is what this is telling me. Okay, so any zeros above 6 are not going to work. So guess what, you guys? I can get rid of them from my list. So anything that's larger than 6, I already know from this test is not going to work. Okay, so let's see what's higher than 6. Okay, well, we know that 6 did not work, so I'm going to cross out positive 6. Now, be careful. This is positive and negative 6. If you see here, I only crossed out the positive. I did not cross out my negative because negative 6 could work. Okay, but positive 6 definitely didn't work, so I didn't get a remainder of 0. Positive 8 will not work because it's higher than 6. Positive 12 won't work. 16, positive 24, and 48. All those are things that are either 6 or higher than 6. So you see, you guys, I kind of narrowed down my list some. Isn't that cool? Okay, let's try something else, which I'm going to work on this over here. I'm going to try to squeeze it in. We'll see what happens. Okay, again, I'm going to pick something off of my list, and let's see what happens. If I get a remainder of 0, that means that I found a 0, which we can write in a factored form. So the next thing I'm going to try, you guys, is, I don't know, what's something off this list that looks good? I agree, you guys. I think negative 3 is an excellent option. So I'm going to go with negative 3 because I have a negative 3 right there. So again, these go in the box. So I'm going to put negative 3 in my box. Okay, and again, instead of listing all these out, if you don't want to, you can go straight into here because we're dealing with the same coefficients. Okay, nothing happened because we didn't find a 0. So I'm just going to list these coefficients out. 2, negative 3, negative 24, 4, and 48. Okay, which if it's seriously irking you that you didn't list those, you can list them. So I guess I'll list them. I need to stop being a lazy mathematician. Sorry, you guys. I'll work on it. All right, guys, let's see what happens. So my goal is to get 0 in the remainder spot. If I do, that means I found a 0, and I'm happy. All right, let's do the synthetic thing. So I'm going to bring down my 2, multiply my 2 to the boxy. 2 times negative 3 is negative 6. Negative 3 plus negative 6 is negative 9. Multiply it to the boxy. Negative 3 times negative 9 is positive 27. 27 plus a negative 24 will give me 3. 3 times my boxy, negative 3 gives me a negative 9. 4 minus 9 gives me negative 5. All right, let's see what happens. My goal is to get 0. Let's see if we can get 0. Negative 5 times negative 3 is positive 15. Let's see, 48 plus 15. That will give me 63. Oh no. Let's look at our remainder. We didn't get 0 for the remainder. Oh no, you guys. This is not a 0 or a factor. So this is still not a factor. So we're sad. No, it didn't help us. But I'm going to tell you, something useful is going to come out of this, and I'm going to show you. Let's look at the signs again. All right, and when I say let's look at the signs, I'm talking about are they positive or are they negative? So 2 is a positive number. Negative 9 is a negative number. 3 is a positive number. Negative 5 is a negative number. And 63 is positive. So what's going on with these positives and negatives, you guys? Do you see how they're alternating? So positive, negative, positive, negative, positive. If you guys see that the signs underneath your synthetic bar are alternating and we don't get zero as a remainder, what that means is you have spotted something called a lower bound. And what a lower bound means, you guys, is that there aren't any zeros that are smaller than -3. So everything under -3 will not work. Okay, so let's get rid of everything that's smaller than -3. Okay, which if they're smaller than -3, they are a larger negative than 3. Okay, so like -1/2 is not smaller than 3. This is closer to 0 than -3 is. So that's not one of them. But -4 is smaller than -3. -6 is. -8 is. -12. -16. -24. And -48. Okay, which technically, you guys, I've kind of eliminated entire numbers. All the positives and negatives of 6 and higher will not work. Okay, so I can even get rid of those. That whole thing doesn't work. Now, I'm not crossing out the 4, though, because the positive still works. Now, something I also need to cross out is my -3, though, because it didn't work. So anytime you try this and you don't get 0 as a remainder, you can cross whatever you put in the box off as well. Okay, but if you see, you guys, I have drastically reduced my possible zeros. I went from having 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 24 zeros to 2, 4, 6, 8, 10. Okay, so I eliminated 14 zeros. Isn't that crazy? Okay, so now I'm going to do the same thing. I'm going to do synthetic division, but now I'm going to pick from my reduced list. Okay, which, I don't know, what would be a good 0 to choose from? I agree, you guys. I think -2 would be a nice choice. I don't know, I'm just feeling this -2 thing. So let's see what happens when I put -2 in the box. Alright, again, nothing has happened, so we're going to be using these same numbers in synthetic division. Okay, which I won't be a lazy mathematician, you guys. I'm not going to give into it. I'm going to write these again, and again, we haven't done anything to the polynomial, so these numbers are going to be the same. So 2, -3, -24, 4, and 48. Alright guys, let's see what happens with -2. Bring down my 2. 2 times -2 is -4. -3 plus -4 is -7. -7 times -2 is 14. -24 plus 14 is -10. -10 times -2 is +20. 4 plus 20 is 24. Alright guys, my goal is to get 0 as my remainder. Let's see what happens. 24 times -2 is -48. Holy hot dog! Do you guys see this? We get 0 as a remainder. Yay! So we have spotted a factor, which makes us happy. Which means that this is our 0. Okay, so the first 0 that works is x equals -2. This is a 0. Okay, so we're trying to find all the zeros, and I also want you guys to write this in factored form. So we're going to have a zeros list going, and we're also going to have factored form going. Okay, so let's see where I can write this. All right, I'm going to write my zeros list over here. So we have a list of zeros. Okay, so far we found one. X is -2 is one of them. All right, and eventually we're going to write factored form, which I'll leave a spot for that right here. Factored form. All right, so we're accumulating our list of zeros right now. All right, so I have -2 is one of the zeros. But if we think back to the fundamental theorem of algebra, which states the degree should equal the total amount of zeros. What is the degree, you guys? Holy hot dog, you guys are so smart. The degree is 4, which means in the end we should have 4 total zeros. So we have one of them, so we're good to go. Okay, so now, just like when we had the graph, you guys, when we got 0 as the remainder, just like when we were doing the problems that I showed you the graph on, we are now going to focus on the depressed equation when we solve. Okay, we are no longer going back to these numbers ever again. Okay, but before we do that, let's start writing our factored form. So my factored form. All right, we have spotted a factor. So the 0 is x equals -2. So in factored form, we do the opposite of that. So it'd be x plus 2. Alright, and now I'm going to write my depressed equation out, which remember we start with one exponent less than our highest exponent. So I'm going to start with 2x to the third, because x to the third is 1 less, minus 7x squared minus 10x plus 24. Okay, so if you see, you guys, we're kind of reducing this equation down. We started with this, and now we have it as this. Okay, so if you can factor, the goal is to try to factor our reduced equation, which this is called the quotient or the depressed equation. It has lots of names. So I'm going to look at this and ask myself, can I factor that? Because factoring is much faster than testing zeros over and over and over. Okay, so if you can factor, you guys, it's much faster to do that than to sit here and keep trying zero after zero after zero. So I have 4 terms, which if you think back to that nifty chart, when you have 4 terms, the only way we can factor is by group factoring. Okay, but I'm going to tell you right now, I'm going to save you some time. Group factoring is not going to work. When we group the first 2 together and the last 2, we will not be able to get the same thing in each parenthesis. So we tried group factoring and it failed us. So if factoring fails us, you guys, we're going to keep doing this process until we can factor. Okay, so now I'm going to use these numbers in synthetic division. So now it's getting a little different. Okay, so I haven't decided yet what I'm going to put in the box, but my highest exponent is now x to the third. So I'm going to write x to the third, x squared, x to the first, and x to the 0. And the numbers I'm going to write are 2, negative 7, negative 10, and 24. Let's do this thing. Okay, now we must go back to our list of zeros. So negative 2 works, so I'm going to ignore my negative 2. So negative 2 works, so I'm going to cross it out now because we don't need it anymore. Okay, so I need to pick from this list of zeros, which let me think. What would be something good to pick from that list of zeros? I totally agree, you guys. I'm feeling positive 3/2 as well. I think that is a stellar choice. So let's do positive 3/2. Let's see what happens. Okay, I'm going to put positive 3/2 in the box, which fractions are our friends, so it's going to be epic. All right, guys, let's do this thing. Bring down the 2. Okay, 2 times 3/2, you guys. Okay, so I'm going to do my fraction work on the side. So we have 3/2 times 2, which is like 2 over 1. Okay, but technically, you guys, don't you see that the 2's are going to cancel out? So we're just left with 3 over 1. So this is just 3. Okay, now if that didn't make sense, you could multiply, so you could go straight across. So 3 times 2 is 6, and 2 times 1 is 2, which that reduces down to 3 over 1, which is 3. Okay, so 2 times 3/2 is 3, so I'm going to slide that bad boy over. I'm going to add down negative 7 plus 3 is a negative 4. I'm going to multiply it to the 3/2. Okay, I'm going to do that over here. So 3/2 times 4, or negative 4. Okay, so 3 times negative 4 is negative 12. 2 times 1 is 2. And negative 12 divided by 2 is negative 6. Holy hot dog, you guys. So this will be negative 6. All right, let's add down. Negative 10 minus 6 more is negative 16. All right, let's see what happens when we multiply 3/2 to negative 16. Remember, the goal is to get 0 as our remainder, so let's see if that happens. Okay, so 16 times 3/2. So 3/2 times negative 16. Okay, so we're going to get a negative. All right, so 3 times 16, that will give us a negative 48. Sorry, I don't know why I wrote 6, you guys. So it'll give us a negative. So negative 48 over 2 times 1 is 2. And negative 48 divided by 2 is negative 24. Oh, man. Holy hot dog, you guys. Do you see what just happened? We got 0 as a remainder. Yay. So that means we have found a factor, okay, which also means that this is a 0. Yay. So our 0 is x over 3/2. Okay, so I can add that to my zeros list. I found another one. X equals 3/2. Okay, so we're going to keep writing this in factored form, and hopefully, eventually we can factor this thing so I don't have to keep going through this process. Okay, so when we do this. Okay, so factored form. I'll keep going with factored form. So we have f of x equals, I'm going to write the previous factor we found, which is this x plus 2 right here. Okay, we found another one, which the 0 is x equals 3 halves. So in here, we're going to do the opposite, which is x minus 3 halves. But remember, you guys, we don't like fractions in factored form. So I'm going to move the 2 to the x. So this will be 2x minus 3. And again, where I got that from, it was x minus 3 halves. But we don't like fractions in factored form, so I just moved the 2 to the front. That's it. Okay, so those are our two factors so far, and then I'm going to write what is left over. Okay, so what's left over is my depressed equation, okay, which I'm going to start with one exponent less than my highest, so that would be x squared. So we have 2x squared minus 4x minus 16. Okay? Now, something we need to be on the lookout for, you guys. If at any point we have a GCF, we must factor it out. Because remember, in factored form, our leading coefficient must be the same as the leading coefficient in standard form. Okay, which if you see, the leading coefficient in standard form is a 2. So at some point, I need to get a 2 in the front of my factored form. And the way we get that is by factoring out a GCF. Okay, which if you see here, is there anything in common between 2, -4, and 16? Holy hot dog, you guys are so smart. This is where the 2 is going to pop out. I'm going to factor out a 2 out of that. Okay, so we have f of x equals 2, parenthesis x plus 2, parenthesis 2x minus 3. And I'm factoring out the GCF out of this one, so this is the only one where each term gets divided by 2. Okay, so 2x squared divided by 2, the 2's will cancel, and I'm left with x squared. -4 divided by 2 is -2, and the x is just going to tag along. And -16 divided by 2 is -8. Alright guys, so we're getting closer, Okay, so now, using this, we're going to try to factor. Remember, we tried to factor up here, but it didn't work. But I have 3 terms, and we can definitely always factor using 3 terms. If you remember, what factoring technique requires 3 terms? Holy hot dog, you guys are so smart. This one, you can either do the quadratic formula, which that will give you zeros, but don't forget to put it in factored form, or you can do slide and divide. So on this one, you can do slide and divide, or the quadratic formula. Okay, so it will be much faster if we just go ahead and factor instead of sitting here and trying zeros out over and over and over. So now, I'm going to write that bad boy in factored form using slide and divide. Me personally, I like slide and divide. I think it's a little faster than the quadratic formula, but it's not wrong to use the quadratic formula. Alright, so I'm going to continue on to this paper. Okay, which, let's see. Okay, sorry guys. Just need something to hold this down. No, don't move. Stay down. Okay, I think it's going to stay down. Okay, so I'm going to continue on. Alright, so I'm looking at this right here, and I want to factor that using slide and divide. So we got my x squared minus 2x minus 8. Alright, so we're using slide and divide. Let's get going. Okay, so we're going to slide a to c, which my a is a 1. Okay, so I'm going to slide my a to the c, which 1 times -8 is -16. So we're trying to find 2 numbers that multiply to be our slide, which is a times c, so -8. Okay, and then we're going to find 2 numbers that add to be b, which my b is -2. Okay, and don't forget at the very end, our final answer, we will be dividing, don't forget to divide, by our a, which our a value was 1. So for my final answer, we're going to divide by 1. Okay? Alright, so let's think here. 2 numbers that multiply to be -8 and add to be -2. You guys are too cool for school. I can't trick you guys. You're correct. It's -4 and +2. Guys, and these are the numbers that go directly into my parenthesis. So we're going to put the -4 in here and the +2 in here. And all I got to do is reduce this down, you guys. So 4 over 1 is 4. So my final answer would be, let's see, I'm going to write it in a different color. My final answer would be x minus 4. And then here, 2 divided by 1 is 2. So this will be x plus 2. Alright, so we have factored out the rest of this form. So our final factored form, you guys. Okay, so we're going to start by using what we had, which is this. So we're going to have factored form. Oh, I probably shouldn't have done that. Alright, so I probably won't have enough space to put factored form there. Why would I do that? As long as you're so silly. Stop doing this stuff like that. I'm just making my life more difficult, you guys. Okay. Alright, so this is factored form, and I'm going to leave space so I can actually write it. Okay, so this is factored form. I'm going to write what I already have. So factored form, we have f of x equals 2 times x plus 2 times 2x minus 3. And then I'm going to write what I got after I factor that, which after we factor that, you guys, we got x minus 4 and x plus 2. So I'm going to replace this with my x minus 4 and x plus 2. So x minus 4 and x plus 2. Bam! Alright, so this is factored form. We have finished factored form. Yay! So this is part of our answer as factored form. Okay, all that's factored form right there. Okay, now we are still missing 2 zeros though, and the last 2 zeros come from here, which remember you guys, the shortcut when we have factored form, to get the zeros, you just change the signs. So my last 2 zeros would be x equals, it was negative 4, but now it's going to be positive 4. It was positive 2, but now it's going to be negative 2. And if you see here, this makes sense because we started with a degree 4 polynomial, which means we should have 4 total zeros. So yay. Alright, so to wrap this up, let's talk about how many real zeros we had and how many imaginary. And remember, the total should be equal to the degree, which is 4. That's my highest exponent. So they should total out to be 4. So if I look here, remember, real zeros are things without the I. So all of these don't have an I. So I have 4 real zeros. I have 0 of them with I, so 0 imaginary. Which means I did it correctly, you guys. I have 4 zeros, which is equal to our original degree, which is the highest exponent. So yay, here are my zeros, you guys. So this is kind of a part of my final answer. And also part of my final answer is this, factored form. Holy hot dog, you guys. That was a tough problem. It was long. We did all this work, but ultimately we had a blast because we reached our final answer. Way to go, you guys.